This video is on the inductive effect. The inductive effect is when an electronegative atom pulls electrons towards it throughout the whole molecule. This redistribution of charge creates partial positive charge that is able to stabilize the negative charge of the anion, i.e. we're stabilizing the conjugate base. The inductive effect is cumulative, so if the electronegative atom is on one position, if we add a second electronegative atom to that position, we will increase the inductive effect and we should see the effect on the acidity of the molecule as a whole. Distance is also important, so the closer the source of the inductive effect, the stronger the effect is, as can be seen in these examples. Observing the inductive effect is relatively simple when you see a strongly electronegative atom. However, certain clusters or functional groups can also have a similar effect, so it's worth noting all the inductively electron-withdrawing groups, pictured here. Now, all the positive effects that the inductive effect has on stabilizing anions can be counteracted by the opposite effect of an electron-rich functional group. So if something has a lot of electron density, it's probably going to destabilize an anion. Here are some examples of electron-rich substituents. The questions you will be asked about the inductive effect will most likely be in relative terms. So we will just be comparing a molecule to another molecule that either has a electron-withdrawing group or an electron-rich group that can then have an effect on its pKa. For example, here are two molecules. Which one of these is more acidic than the other? Pause now. And here's the answer.